All right, Earth Science friends, welcome to our little podcast on density. Density is really important in Earth Science, so let's kind of get right to it, okay? What is density? Density is how much stuff is in a particular space, how much matter is in a particular volume. So how much stuff is in this space, this cylinder or whatever, okay? That would be a measure of density, how densely packed that space is, all right? So let's think about this. If I have a box, now pardon my artistic skills or lack of them, but let's say I have a box, okay? It's a three-dimensional box, and I put some marbles in it. Here's a marble, here's a marble, here's a marble, okay? And that's all I put in there, 3 marbles in this box. Let's say if I put this box and its marbles on a scale to measure their mass, let's say their mass maybe was all of 10 grams. And if we measured the box to get its volume, how much space the box occupies, maybe we measure this side times the height times the width. Maybe we determine that the volume is 100 cubic centimeters. All right. Now, if I got a second box, same size, all right, let's say it's the same size box, okay, but I jam this box, so let's say the box is the same, so we know our volume is going to still be that. But I jam this box with as many marbles as I can possibly fit into it. It is just chock full. There's no place where there's not a marble, okay? Packed full, all right? Now, if I mass that box, you can imagine there's going to be considerably more mass in that box than there is in the first one. Maybe the mass of this box might be 500 grams because there's so many marbles in it, okay? Same amount of space in each box available, but this box is much more dense with marbles. If I tried to put my finger in that box, I could probably not get it in there because it would be so packed with marbles. It's very dense. Whereas this box over here is not very dense, okay? It's the same stuff, but there's not as much stuff inside the box, so I could get my whole hand in there and move it around if I wanted to. It is not very dense, okay? That is how we think about density, how much stuff is packed in that space. And we measure it by determining the mass and the volume. All right, so density is really important in earth science because it tells us if one substance is going to sink or if it's going to float relative to some other substance. That's going to make a lot more sense as we start getting into things like weather and so on. But for example, if an object is placed in a liquid, let's say we've got some water here, and I put a piece of I've got a piece of lead. Let's say this is oh yeah, that's my great artistic skills. I have a piece of lead, okay? Lead is quite dense. And if I drop my lead into my water, my lead is going to sink because my lead is more dense than water. It will just go straight to the bottom. On the other hand, if I have a cork, and I put the cork in the water, okay, there's my little cork, my cork will float because my cork is much less dense than the water. So it will just sit on top of the water and bob along, okay? Sorry, just want to get rid of the ink here, okay? This is really important because in earth science, when we talk about weather, when we talk about oceans, when we talk even about the molten lava and things in the layers of the earth. There's a lot of sinking and floating, rising and falling that happens, and all of that is due to how dense substances are and how dense they are compared to each other. And then one substance rises, one substance falls, and that causes a lot of what we observe going on with Earth's atmosphere and so on. Okay? So how do we determine density? We've already touched on that. We determine the mass of the object. How massive is it? How big of a space is it? And then we do this little calculation. We just divide the mass by the unit volume. So if we go back to our marbles and our cube, one, I can't really remember, one had like 10 grams of marbles and 100 cubic centimeters of cube. So that would be the density. So 10 divided by 100 is going to be 1/10 or 0.10 grams per cubic centimeter. So that would be the density of that much less dense cube. But remember our very dense full of marbles cube, I believe that was 500 grams divided by 100 cubic centimeters, which would be 5 grams per cubic centimeter. So for every centimeter of that cube, there would be 5 grams worth of mass. So 5 grams per cubic centimeter is much more dense than just 1/10 of a gram per cubic centimeter. So a big difference in density, okay? Now please note, grams per cubic centimeter does not necessarily always have to be the units for density. If you're measuring something much, much bigger, you might use kilograms per meters cubed or something like that. But in our class, it is usually going to be grams per cubic centimeters or grams per milliliter, because remember, milliliters and cubic centimeters are equivalent units of volume, and they mean the same thing. Okay, so an especially important density to keep in mind, something that is easy to remember and common everywhere, is water, and its density is 1 gram per milliliter. So if you have a milliliter of water, you will know that it weighs 1 gram, or its mass is 1 gram, and that is water's density. And so we can compare other things to that. Is an object more dense than water or less dense than water? And that's useful. It helps us kind of understand something about that object. Okay? All right, that's it for density. Thanks for watching. I'll see you next time.